Today we are going to talk about crankshaft position sensors, specifically Hall effect sensors. We're going to go over what a crankshaft position sensor is, Hall effect versus magnetoresistive, how a crankshaft position sensor works, why it's important, diagnostics, and more. What is a crankshaft position sensor? Crankshaft position sensor monitors the position and rotational speed of the crankshaft. It sends this information to the engine control module, which uses it to control ignition timing, fuel injection timing, and engine synchronization. Hall effect versus variable reluctance. Hall effect crankshaft position sensors work by using a magnetic field and an external power source to generate a digital signal that the ECM can interpret. These sensors typically have 3 wires, one for power, one for ground, and one for the signal output. When a toothed wheel or reluctor ring passes by the sensor, it interrupts the magnetic field, causing the sensor to produce a square wave signal. This digital output makes Hall effect sensors very good. They are less affected by electrical interference and small variations in the air gap between the sensor and the reluctor. Variable reluctance crankshaft position sensors operate on a magnetic field resistance and do not require an external power source because they generate their own signal. These sensors typically have 2 wires, one for the signal and one for ground, making their design a little more simple, but they do require more precise installation. As a reluctor wheel or tooth gear rotates past the sensor, it induces an AC voltage, producing a sine wave signal that varies in frequency and amplitude depending on the engine speed. While variable reluctance sensors are very sensitive and capable of producing detailed crankshaft position data, they are more prone to being affected by dirt or variations in air gap, which can lead to inaccurate readings or failure. How does it work? A Hall effect crankshaft position sensor works by using a small magnet to detect the movement of a reluctor wheel with teeth and gaps, which is attached to the crankshaft. As the crankshaft spins, the teeth and gaps pass by the sensor, changing the magnetic field around it. When a tooth comes close, the sensor detects a stronger magnetic field and sends a signal to the engine control module. When a gap passes, the magnetic field weakens and the signal changes. The ECM uses this signal to figure out the crankshaft's exact position and speed. With this information, the ECM knows when to fire the spark plugs and inject the fuel at the right time, keeping the engine running smoothly. Here's an example of a digital signal sent by the Hall effect sensor. Why are they so important? The Hall effect crankshaft position sensor is a very important component in the engine because it provides precise crankshaft position and speed data to the ECM. This information is very important for ensuring accurate ignition timing and fuel injection timing. By synchronizing these engine functions, the sensor helps the engine start properly and operate without misfires or hesitation. It also contributes to overall engine performance by optimizing fuel efficiency and reducing harmful emissions. The sensor also enables advanced engine diagnostics and trouble code detection, making it easy to identify and fix issues when something goes wrong. Since most engines rely on this sensor for proper operation, the engine would struggle to run or may not even run at all if the sensor fails or provides incorrect data. Here's a 2019 to 2021 Ford EcoBoost. Going to look at the location of this crankshaft position sensor. We got the pulley right here, you can see the teeth, and the sensor's right here. Here's a picture from AllData of a 2017 Chevy Silverado where you can see the crankshaft position sensor is located on the side of the block and reads those teeth you can see from underneath right here. Let's take a look at some diag for the Hall effect crankshaft position sensor. First, we're going to take a look at this GM 3.8 liter and how it works. The crankshaft position sensor provides a signal used by the ignition control module to calculate ignition sequence. The ignition control module also uses the crankshaft position sensor signals to initiate 18 times and a 3 times reference pulse, which the PCM uses as reference to calculate RPM and crankshaft position. On this specific GM model, you can see we have our crankshaft position sensor here, and it matches up with this reluctor. You can see the magnet matches up with this reluctor wheel right here, which is connected to the crankshaft. You can see we've got our 18 pulses, our 18 teeth on the outside circle. We've got our 3 big teeth on the inside. We're going to go ahead and hook up the picoscope on a 2000 Buick LeSabre and see just how this works. On this GM 3.8 liter, we got the picoscope hooked up to the crankshaft position sensor. Crankshaft position sensor is right down there. We are hooked up into the light blue and yellow signal wires that go into the ignition control module. Here is the wiring diagram, connector view, and description from ALLDATA. Here's a better look at the wiring diagram. Here at the top in the middle, you can see the crankshaft position sensor. The 2 wires on the right that go down to the ignition control module are the signal wires that we're tapped into. We get to the light blue and the yellow wire right off the ignition control module. The light blue is the 3-pulse signal, and the yellow wire is the 18-pulse signal that we will take a look at here in just a second. Taking a look at our signals on the Pico, you can see here on the bottom in blue, we have the 18-pulse signal, and here on the top in red, we've got our 3 times pulse signal. You can see the 3 big teeth up here. Here, if I pause it, you can see we got the smallest gap, the medium-sized gap, and the largest gap. Here's our reluctor ring connected to our crankshaft. Here, right here, you can see we got the small gap, the medium-sized gap, and the largest gap right here. With the crankshaft position sensor signal grounded, we're going to go ahead and try to start the car. With the crankshaft position sensor unplugged, we're going to go ahead and try to start the car. Grounding the sensor signal and unplugging the sensor both did not set a code. Another thing that can fail with the crankshaft position sensor is the tone ring. Taking a look at this tone ring from a Ford EcoBoost, you can see if one of these teeth or the tone ring itself gets damaged, it could interrupt or mess up the sensor. Thanks for watching. I hope you enjoyed the video and learned a little bit about crankshaft position sensors.